Appreciate those who are showing your videos. If you can, awesome. If you can't, no worries. I like seeing faces. It's fun. More fun that way too. So yes, my name is Brian Coffey. I'll get us started here. This is the goal here is to talk about how to implement ST Math for the best bang for your buck. So a little bit about me, so that way I get a little street cred with you. There's two things that make me, I think, important for you all today. First is I was a building principal for 3 different buildings where I used ST Math in those buildings, implemented it in 3 different buildings in 2 different districts, a K-4 elementary school, a 5-6 intermediate school, and then a 5 through 8 building. And I was excited to implement, learn a few things there. And what I'm going to show you today, we're going to look at a lot of data, but it's going to be friendly data. Okay, I'm going to try to unpack it as best I can. What I'm going to show you, though, is data that I wish I had seen back in the day when I was a principal implementing ST Math. So I'm looking through it that lens. If you're a teacher or a coach or district coordinator, that's wonderful too. We'll look at through that prism as well. Honestly, if you're around kids, I think this is hopefully beneficial. And you can look at it through that. The second thing that I think is of merit about me is I have 4 children, and they've all used ST Math for like the last 10 years since I've been around the game-based learning program. And each kid is unique in their own way, right? But the commonality they have is they are accelerated in math. And I believe ST Math is one of those variables that help build their relationship to math in a healthy way. And they also believe they can solve awesome math problems. And so that's some fun things about myself. The goal, talk about your ST Math implementation to get the best bang for your buck, but really the point is the greatest impact for learning. So we're going to try to identify that for y'all today. So I have 3 big ideas that I want you all to walk away from today. 3 big ones. The first 2 are serious. We'll be kind of in the grind a bit for some stuff, but then the third one will be a little bit more fun at the end. Say it's like open or present. So keep that in the back of your mind. Anticipate opening a present. It's gonna be fun, virtual one. But we'll walk through. Here's the big ideas. Skin in the game. Don't skip a week. That's about students. We'll talk about that. All about our middle name, which is research. If you're not aware, ST Math was created by Mind Research Institute. So research is a heavy emphasis of what we do. Best practices, those kind of things. We'll take a look at that. And then last is something cool and circle back around to our mission. So with that said, let's take a look at our first big idea here, skin in the game, don't skip a week. Before I jump there, I do want to preamble this. I am going to show quite a few charts and graphs and data like I previewed a little bit there. The whole idea here is really to get to the point of the graphs and what they're saying to us, not to dissect them in a granular level. I'll do that for you because for time's sake, but also if you're like me, when you see new data, it takes about 5 minutes to kind of unpack it. You look at a chart, you're trying to figure out, well, what's the X and Y axis talking about? For this sake, I'm going to unpack it kind of quick to the point so I can show you what we're talking about. Make sense? We fair with me? So hopefully it's not too quick, but I am going to try to, for time's sake and for our brains not to hurt too bad in this afternoon, to get going. All right, so here's our first big idea, skin in a game, don't skip a week. Okay, we recently at ST Math conducted an analysis of a sample of ST Math districts and schools and students from across the country to determine what it takes to increase ST Math impact. Pretty cool. We recently did this with our data team, and I was involved in some of that analysis as well. Reminder, before I jump into this data grind here, I want to remind you of a few things, and I'm sure you're aware of a couple. Minutes that students are on ST Math turn into puzzles collected, right? We know that, and we call that learning velocity. Puzzles collected turn into standards covered, right? For that grade level. When they collect those puzzles, they're covering those standards, they're mastering those standards for whatever grade level they're on. And standards covered turn into submitted achievement score, right? That's your state assessment. That's the goal. That's where we see a lot of our impact play out for learning, let alone the day to day where students are engaged, having fun, and having this belief I can do math. So we see this kind of cycle happening. And I want to just point out in our analysis here, we took a look at these minutes and puzzles and standards covered. So let's jump into a couple more things here. To accumulate minutes, puzzles, two factors have to multiply together. First is the average number of minutes per week a student is on ST Math, so that's one factor, multiplied the number of weekly attendance. Catch that, weekly attendance. So I think it's a kind of a given. We think about how many minutes the students are on each week. Sometimes we don't look at how many weeks in a given year are they on. And you're going to see some interesting correlations here about that. Real quick caveat at the bottom here, attendance for us equals if a student logged on for a week greater than 10 minutes. Got that? So if they logged on for more than 10 minutes a week, we counted them. They didn't, if they're less than that, we didn't count them. We also know in this analysis, there's a skipping issue. So about a third of our students in this sample skipped any given week. So they weren't regulars on a regular. I'm not watching the chat window just because I'm in my flow, but if there's Q&A things I can circle back to, or Emily, Michelle, and you're like, hey, you need to check on that, let me know. Oh, before I go to this one just quite yet, you just saw the first chart. So I'm going to jump in. I'm going to throw you 3 charts that are kind of similar, but I'm going to unpack them for you as accurate as I can, and it'll be fun. So here's our first one. This is all the students in this sample, about 25,000 students. And this is looking at their end of year minutes that they were able to be on ST Math. The target is around 2,000 minutes in a year. We want students to be on ST Math, about 2,000. We have 1,800 plus, really. So what this is showing here, I'm gonna move my mirror, here we go. All students, what they accumulated in that given year. Again, reiterate, at least 10 weeks they had to attend. So 10 minutes per week and at least 10 weeks of attendance. And we did not filter out any minimum requirements for that week other than the 10 minutes. All right. So what this shows here, and you see this big spike at the left here, right? That's basically barely in minutes on ST Math, just so you know. They didn't have much time on ST Math in this given year. And that's a large swath. Now I will say this, we know that inside every district, there are some great schools and in fact, some great classrooms who are using ST Math. And then we know inside every district and every school, there's some classrooms, some grade level bands that are not using ST Math. So this was taking into account all that, right? So this is the large grouping. Let's go a bit further. Let's take a deeper look in here. Here's our next graph. Now we've aggregated to all students with average minutes of greater than 40 minutes per week. Okay, now we've aggregated that, right? This is counting students greater than 40 minutes a week. What you catch though, what you see, if you check this out, we're still quite a bit below our target, not even close to 2,000 minutes in the given year. So what this tells us, reducing low minutes and week doesn't fix the problem necessarily, right? So even if we have students who are greater than 40 minutes per week, it doesn't mean necessarily that's going to be a lot of time, because it's not necessarily about just how many minutes a week they're on. Check this one out. We aggregated even further, and we identified, what about students who showed up? Y'all ever heard that 90% of success is showing up? 90% of success is showing up, just being there? Well, we found it's actually like 85%. If you show up about 85% of the time in a week, that's going to have a correlation to some awesome time with ST Math. So students who showed up on an average of 85% of the time hits the target of 2,000 minutes in a year. Actually, above it, if you see the peak, it's over 2,000 minutes in a year. So these students who showed up every week, about 85% of the time, they were getting way closer to that goal of hitting that target. The peak is actually over 2,000, pretty sweet. So check this out, minutes per week. This is the point. Minutes per week increase with percentage weeks attended. So as you can see here on the left here, it's describing the minutes per attendable weeks to the amount of weeks they attended. So they both have a correlate together. And they're every time they keep showing up on a regular basis, about 85% of the time, all of a sudden the time for the year increases substantially. Here's why. Attendance and minutes per week matters. Why does fixing weekly attendance work so well, even without an extra focus on the amount of time each week? Because there is a relationship between percentage attendance and minutes that they are actually there. We found that the higher the percent of weeks a student attends, the more minutes the students play for each week. Catch that. The higher the percent of weeks the kids showing up, they're not skipping, the more minutes the students will play for each week. Students become used to productive struggle. They're familiar with it. Therefore, they solve more problems and become problem solvers, right? So if they're showing every week, they're getting familiar with our gameplay, the productive struggle, the perseverance when problem solving. And so they're more enabled to play longer and extended periods of time. And that's going to solve the issue of time in a given year. So first big idea there, don't skip a week. Show up. All right, let's go into some data that backs this up for us. We had a study, Harvard did a study on us just last year. They used their Proving Ground team to review ST Math's impact. So in May 2020, Harvard explored ST Math's implementation and the impact we have on student learning. And here are some of their key findings. They check this out. Increased ST Math usage was associated with higher math gains. So they took a look at state end of year tests, so SBAC, PARC, in 4th and 5th grade, and they pulled these couple years of using ST Math, and what they found was increasing ST Math usage from fall to spring by more than 10 minutes a week associated with higher math gains. Just 10 more minutes a week, and we know 85% on average a week showing up, huge math gains. Check this out, this graph, one more here. So for every 10 minutes a student was on ST Math, it had a direct correlation to their math state test score. For every 10 minutes they had more on ST Math. All right, so here's what we can do internally. Here's our teacher console or our admin console. We can look at, and I'm sure you're familiar with this, productivity, right? You can see this week's average time in ST Math, last week's average time, and the overall average time that students are on ST Math. And you can kind of see here over the holidays, winter break, we took a little bit of a dip, and we're maybe in this one building down a little bit. So if I was an administrator or a teacher in this building, I'd say, okay, we need to get our weekly averages kind of back up. But really, we know also it's about students showing up every week, and y'all can do that. You can get down to that granular level to see a student's if they're dropping in minutes each week. So as you can see in this chart, you can see each of their weeks, each of their months, how much time they're on ST Math. So if I were this teacher in this classroom or this administrator looking at my building and looking at grade levels, I would identify, hey, I need my students to be on every week. And we see here, this isn't a student problem. This isn't a student issue. This is an adult control thing. We have that power to facilitate that time to direct students to be on ST Math. And I'll show you why they want to be on ST Math. All right, so say you are in a building, you know some grade levels in your building that aren't off to a great start. Guess what? It's not too late to get a jump start. So right here, you're seeing right in this graph, each line is a school who started the year off below average in usage. Then once winter break concluded, they increased their above average after winter break. They got focused, they got serious. So it's never too late to jumpstart your school year. I hope you guys are encouraging that to your other colleagues and you're leading that. It's never too late. And that's a really big point. We didn't really see much correlations. You know, that earlier deal, 85% of the week, they showed up each week. Some of it happened later in the year, but then they started consistently showing up every week. And that had a great correlation to state achievement score. All right, hopefully you've seen this. This recommendation, this time that we focus on a lot, it's buffered, it's backed up by all that research I just showed you from the Harvard Proving Ground study, from our internal matrix. we recommend this time because we see how it plays out. So in 2nd grade through 8th grade, about 90 minutes a week, we want students to be on ST Math, and grades K through 1, about 60 minutes. Let's jump on to our next big idea. It's our name, it's research. We're always looking, what's the best practice? What's the bang for your buck? And ultimately, what is going to be the greatest learning impact? And so that's what we are doing all the time. We're researching, we're internalizing things. And I want to point this out too, that's kind of neat. Mind Research Institute is a nonprofit organization. So our board and colleagues, myself included, we are responsible. We are held to a standard of learning impact, not for financial gain and profit. Everything is measured, how much learning is occurring. So that's a sweet thing, I think, for research and what we're trying to look at here. All right, so let's take a look into some pretty neat research if you haven't seen this before. So this is West Ed, an independent review agency, and they took a look at ST Math usage in a year in different states, schools, and assessments. And here's the report. They did a cross-state evaluation of ST Math usage and math performance in those states, and they submitted it back to us. Here are their findings. So in 2018, West Ed study found schools that consistently used ST Math outgrew similar schools in their statewide rankings. So here, check this out. This doesn't say it here, but this was across 14 different states, many of you included. My state in Ohio was included in this study. And this compared us through 11 different state achievement tests. So again, Smarter Balance, PARC, AIR, STAR, all that good stuff. And it was a sample size of over 42,000 students, over 42,000 students that were urban, suburban, and rural. So all over the country in all kinds of schools. And what it showed, what they found were schools that use ST Math when compared to schools that didn't use ST Math in those given states, we outgrew them by 14 percentile points. It's pretty awesome. And I think it's also important to know this is not one test, one sample size, one study 10 years ago in one building that was suburban or whatever. This is a broad swath in real time of all our schools that were using ST Math at that time. Let's dig in a little bit deeper on why we have a philosophy at ST Math of keeping kids on grade level. I think you've heard of that hopefully before. And that's a big, we're a big proponent of keeping kids on grade level. We're going to take a little dive into a progress monitoring tool and how that shows how we can be effective. Remind us though, we're not focused on practice. We're focused on conceptual learning at ST Math. We're not about drill and kill and rote memorization or just practice. We want conceptual schema building. And here's how we can keep kids on grade level throughout the year. We know at the end of the year, they're going to be assessed, the students are, on whatever grade typically they're at, that they're working on. So it's imperative that they have exposure to grade level content. We also know that by and large, a lot of students who are moved off of grade level are disproportionately students of color, students identified on an IEP, students who are in a lower socioeconomic bracket. And those students, unfortunately, rarely catch up to being on grade level. And so we are a big believer in that equity and access, that DEI lens where students have opportunities to be successful on grade level. Let me show you how we do that with some data. This is pretty sweet. So lean in if you haven't already. So we use a progress monitoring tool called iReady. I'm sure some of you all are familiar with it. So check this out. This is their progress monitoring tool that identify what grade level these groups of students were on. Okay, but they played a 4th grade game inside ST Math. This was operations and algebraic thinking. And I don't know if y'all are aware, but inside every game students play when they first start on a level, there's a beginner's part of the game sequencing, then there's a medium challenging game, and then there's the hardest part of that sequence, right? And it kind of builds up. So in here, you're going to see this kind of middle spike. That's the challenge. That's the hardest level at the point the students are playing. So the students who were in this on grade level in this 4th grade game, it took them about 8 or 9 tries to get through the hardest challenge. What happens to the students who are 1 grade level back? It took them about 13, 14 tries to beat that hardest level in ST Math. How about 2 grade levels back? Took them about 2 more tries than the 1 grade level back. Took them about 16 tries to get through. What about 3 grade levels behind that this progress monitoring tool said? Took them under 20 tries, about 19, to get through this hardest challenge in 4th grade. Check this out. This is awesome. This is mastery. This isn't proficiency. This is, hey, I 100% got this standard. I played it from every which way. And y'all who know ST Math know it well. When you play and you win a game, you beat a game, you beat a level, you have to justify your reasoning. You have to demonstrate you know what the heck is going on here, and you can beat this at different angles. And I bet you these students who are 3 grade levels back, they may have just needed 10 more minutes a week to do this. Just 10 more minutes. And how powerful is 10 more minutes versus playing a grade level that they should be on versus moving a student off of grade level? And who in the world knows if they can ever magically catch up to that grade level? Not too much research shows that, but we have that to back us here in ST Math. Let me just remind you why our gameplay is so fun and why we can do this, why we can keep kids on grade level. So check this out. We have a belief in a low floor, high ceiling. So the low floor entry point means students can come and start our games wherever they're at. And we scaffold on up. We build that conceptual schema so they can have a great foundational knowledge to solve a problem. But we have a high ceiling too. So that means that student can go as fast and as far as they are capable of doing. So I'm going to move this slider. This is a 3rd grade game. This is Gigi on a cycle rolling out on a number line. And if you recall this game, the hardest part to get to is estimating fraction addition with unlike denominators. That's where we want to get them to. But before we get them to that point, we have them playing this level right here, estimating fraction addition with like denominators, right? So it's before the unlike denominators. But before that, we're having students visualize fractions. So we're giving them parts to a whole here. We're just kind of getting them used to visualizing that fraction. And then before that, we have students just visualizing whole numbers as one part, but also getting used to and familiar with that number line. So again, we're scaffolding them that. We're building that conceptual understanding that they're learning, and that they can use as they solve higher complex problems. Not about the practice, it's about that schema building, concept-based approach. Last thing on research and data, and this is really key, we're for all students. So let me show you a couple of things in subgroup land here. So if you see this graph, at the top of this graph here are students identified gifted, on down to students who are EL learners or special ed students. And what this is before ST Math was ever introduced to these students. And we've got students, and this is their state achievement score, right? So not surprisingly, students who are identified gifted on their state math test were 91% achievement score. Students who were EL learners, achievement score around 94%. And then students on an IEP, about 11% achievement score. What happens when we introduce ST Math? Check this out. In every subgroup category, students grew. Even in the gifted category, check this one out. Students grew to 98% achievement score. So 7 percentage points increase. How about EL? We almost 10 percentage points increased that achievement score. And in special ed, more than doubled their achievement score when ST Math was introduced. So this shows you, we're not just saying we have equity and access, we're showing you, we are for all kids, all learners. When they are playing ST Math, they can both be remediated and enhanced wherever they're at in their subgroup identification. All right, let's end this session here. I think we've got a little bit of time, and then we'll do some Q&As. I do see some chats coming up, and we can do some Q&As here. Last one, the big idea is something cool in our mission. And it is like opening a present. It's pretty fun. I hope you enjoy this. Not everyone has seen some of this data before, so I'm excited to share it with you all. So something cool we do around ST Math is, and internal colleagues, we anticipate every year Christmas morning, not just for our own households that we celebrate it, but also for data with ST Math usage on those Christmas mornings. So check this out. This is Christmas morning. This graph right here, 7 o'clock in the morning, all of a sudden we have this spike happening with ST Math usage out of nowhere. And what happens is students are opening their presents and they get that new shiny device. And what do? They start playing ST Math and they do it all day. So it's kind of fun. Between 6 and 8 a.m., it holds steady for an average of about 1,740 students at the start of the session. And they hold up to around 10 p.m. at night when I guess the sugar high crashes for them. And again, this is puzzles by hours. This is the amount of puzzles collected. And as you've seen, when students are on ST Math at time and they're collecting puzzles, that's learning. It's happening. So that's pretty sweet. And then I got one more graph for you. Do you remember back in March 2020, the world went upside down? Well, we've identified that in ST Math world as Pi Day. We call it Pi Day because of this chart right here. This is fun. So this was before Pi Day, the average minutes per week. You see we're a little bit below our threshold, depending on what grade levels you are. What happens though when the world goes upside down and students all go home and there is no Google Classroom? Parents are out of their minds with figuring out what to do. We all were. And what happens? Our minutes per week went up. And here's why. When students went home, students were like, I got to do something. So they went on ST Math. Parents were like, hey, this isn't difficult. This isn't a huge hurdle. Get on ST Math. Teachers were like, hey, I know learning is going to happen. That's definitely one of my bullets you're going to do. Play ST Math. And all this is to say, when we know students are on ST Math, that is well time spent learning. And it's good quality learning. And I know there is a lot of conversations about quantity versus quality. In ST Math, it is definitely good time, good use. The screen time is purposeful. It's not going to be diluted. And we're not asking for forever, just a chunk of time per week, maybe 10 more minutes per week. And this can happen. All right, I'm going to end here with this. And this is a bit of our mission. I like this a lot. So I've mentioned this throughout a bit. We want students to live out a skill set that does meets the world's challenges. And that's actually Minds Research Institute's mission. It's to equip students to be problem solvers so they can solve the world's most challenging problems through a math skill set. And to do that, to become problem solvers, they first have to struggle and be productive in playing math tasks. And this is what this says. This is why teaching with problem solving is important to learning. This is from the National Council of Teachers of Mathematics. Many of us are part of those councils. Heck, I just came from one in Georgia. It was amazing. And that's their thing. They're saying we need students to play non-routine, tantalizingly tricky problems, tasks that they build up a skill set of being problem solvers, being creators, being critical thinkers. But to do that, they have to persevere when problem solving. They have to be able to identify what kind of concept is happening so that they can understand the why behind some of it. And then when they've got something, when they learn something, they can transfer it over to solving another thing in another scenario. Remember, just basic understanding does not necessarily equate to knowledge, but applied learning, applied understanding equals that knowledge capacity. And that's what we're about. We want students to be able to problem solve where they can apply that learning that they've got from one scenario to another. And in ST Math, that's what we're doing. We're constantly scaffolding up. We're constantly blending different standards. We have associated standards inside the game to different games that they're playing. And in an effort, they can see a whole web of math standards. They don't even know that they know it conceptually, but they can use it and they can leverage that to eventually solve the world's most challenging problems. And then this is Craig Tapo over here on the left. He wrote a book called The Game Believes in You. And there's a little excerpt. There's a lot of stuff in ST Math in there too. This came out of that book. a few years ago, and he went into a lot of different school districts. I think DC was one of them, and in that district, he saw the great impact that ST Math had on student learning. That is my session for you all. I appreciate your attentiveness. Hopefully, you got a few cool ideas there. Again, if you could take away anything, think about
we do have a
how
few
you can
questions.
Yeah, that'd be great.
There's a few questions in the chat. Some of them wanted to have the copy of the data to look at.
Sure.
And there was one that was also in our Evo. And if someone has a question, they're also welcome to unmute if you want to speak to Brian directly.
What I'll do is I'll put on Wova. Is it Wova? Is that how we call that app? Wova. I'll put on there the slide deck. So, and this has all the graphs and charts, and you can show to your district folks, your staff, your other colleagues in your grade levels, some of that stuff to convince them. Because I do think sometimes we can know, oh, this is great, this is funky, my kids love it, they engage with it. That's one thing. But when we really see the data and we see the proof in the pudding, and we see how the needle can be moved for learning impact, you might think, oh, I really need to make this a priority, a station rotation each week. And again, the more time kids are on each week, the more familiar they'll just be with it. And they'll have that, we talk about grit, talk about agency, they'll have that in spades. Well, I'm not going to keep you. You're not on the clock.
One question I see here,
yeah.
In the chat from our dashboard, one question from Lauren was, how does the implementation change from year 1 to year 2 or future years?
So that's something that can have a little bit of variety. For me, in the buildings I was in, I saw year 1 as teachers just kind of getting used to having it as a station or a set aside time. And they were more so facilitating that time. In year 2, and maybe even towards the end of that first year, but definitely in year 2, leveraging our visual puzzles, our games inside their lesson plan a little bit more. So they had it instructionally embedded. So they started using, like number talks, they started using it like a puzzle talk. And they would open a unit of math with it. They would maybe do a check-in or an end of the unit check-in with an ST Math as a puzzle talk. And we do have puzzle talks that are built in grades pre-K through 8, so that a teacher can, at their discretion, pull it in. So that would be one way in which I saw that nice transition in the second year, where teachers started using this as an instructional tool than just a blended learning model should be where teachers, hey, grab something from that personal path that students are playing with and pull it into that instructional day and interweave it in that lesson in a given week. Because a couple things happen. One, it reinforces to that student the priority. Hey, I want you to be involved in this. But 2, it allows that teacher to take something they just learned visually and pull it into their, their traditional lesson they've got going on. And as a building principal and as a teacher, this. Things you illuminate, you prioritize. If you're not talking about it, if you're not using it, if you're not really blending it into your daily life, what you're doing instructionally, it's not going to be as big of a priority. Those are just a couple of things off the top of my head. I'd say year 1 to 2 occurred. Certainly also thinking PLCs or TBTs or whatever you call your teacher teams. Having a healthy competitive nature is great. So we talked a lot about who's up, who's down for the week or for the month in terms of time in that ST Math world. Puzzles collected, those kind of things. I think that's very important to do that.
And I have another question in the chat. How many minutes of math instruction do your teachers get in a week? Do they embed this in already allocated minutes, or is there a special time for implementation? That was one she asked to the general group.
Yeah, I think I'd say on average 60 to 70 minutes a day would be potentially for a math block, grades 3 through up. But K to 2 could be a little bit less, more like 45, 50, but I'd love to hear whatever one else. And I would say the special time for implementation is really up to you. You can have, again, I said the station rotation model is a perfect space where ST Math can be one of those stations. It could be also as you start your math block day, that's the first 15 minutes of class. They're all on ST Math. If you have a computer time that week, they could do that too. It could be right after you came back from recess, everyone jump on ST Math because they're already fidgety and excited. Their energy's crazy, a little stinky. Sit them in chairs and they can focus on ST Math for a minute. See, the consensus is around 70, 75, 60. So 60 to 75 minutes. That's your math block. And then where you insert ST Math, it can be 3 sessions a week of 30 minutes each. It could be 5 sessions a week of 20 minutes. That's why it can fit well in a station. I do think, though, the real urgency is never too late to jumpstart. So right now, go back to your schools, get them going. It's not too late. And also just that weekly consistency of showing up, just getting on ST Math, logging in so that they're familiar with it is really key. And that's a teacher mindset too. Like, I need to prioritize this on a regular basis in my classroom and not let it go by the wayside. Well, if there's no more questions, I think it's a great time for everyone to go get your coffee or restroom break before the final closeout session. How's that sound to y'all? Good? Okay. Thanks so much for coming. Appreciate your time. Have a good rest of your afternoon.